So today we're talking about right triangle twists in another arrangement. Last week we talked about right triangles in loops of 6. Today we're talking about them in loops of 8 and loops of 4. So I have several examples here for you, and then we're going to fold one together. The simplest version of the structure is if you take the same twist and keep it on the same side as you're alternating your twist A and twist B, and that forms a mirror symmetry line. So if you have two twists on the same side that are connected to each other but opposite rotation directions, then you're going to have mirror symmetry between the two, and you can continue mirroring all the way out. This woven octagons pattern, which is named for the back side, is an example of if you just take a twist and then draw your mirror lines perpendicular to the pleats coming out of it, then you can define your whole tessellation like that. You can also do that with open right triangle twists, and we're going to be using those open right triangles and the closed right triangles on the same side today in our folding. So if you haven't learned about open right triangles, I'll make sure to have a link down below to my video on those. So next up, you can take the same twist and alternate it on opposite sides, whether you're working with the closed or the opens. And you can take different twists on opposite sides. Today we're going to be doing different twists on the same side. Here I have lots of space between my twists. If I was folding this more for myself, I would space them denser together, but this was for a class, thus the pen marks, and so they're spaced a little further out. So next up, this is something that is almost alternating, but not quite. And you see I've already got it in a frame here that I'll discuss at the end once we have finished our folding. So if you're folding along with me, grab a grid that's at least 24 fold. I've got a 24 fold single diagonal grid with diagonals going through the center. And we're doing a practice piece today, so it doesn't really matter what grid you use. We're not going to have it be centered on any position of rotational symmetry, because that would require way too much prep and too much counting to actually get that to happen for this pattern. So for today, we'll find our center. And like I have been showing, we can find the center by folding in half in one direction and then the other. Or if your grid is small enough, you can eyeball it. And I'm going to show you how to generate these patterns for yourself, regardless of which choices you choose for twists. So we're going to start in the center with a closed right triangle twist, mostly because that is a position that I can easily specify. And we're going to make this twist right-handed, just from my personal convention. And squash. And then what we're going to do here is make our loop of 8 such that our twists are touching tip to tip. And this is something that if you're folding twists on opposite sides, like say this pattern, you won't necessarily have your twists touching tip to tip, but you'll have some target spacing between them on the diagonal pleat. So we're going to go for touching tip to tip, and that means that my valley fold for the next twist comes exactly to that tip point. And I'll zoom in a bit here. And the mountain following one spacing away. And then we want to put an open triangle here. So we're going to leave this triangle open, putting in our remaining line on the far side of that triangle, and then the valley even further out. So like I mentioned earlier, if you haven't folded open right triangle twists, then check out, last week's video also used open right triangles, and I'll make sure to drop a link below once we're done streaming to my video where I introduced these twists. Okay, so next we want to fold our closed twist, because remember we're alternating. So all the neighbors of one twist are of the other type. All neighbors of twist A are twist B. All neighbors of twist B are twist A. And so we want to find the next position where we can put a closed twist. And here's where the structure of the tessellation becomes important, because we don't just want to put whatever twist we want. We don't want to put it in this orientation, because that's going to lead to the same structure as last week. What we want is for our diagonal to go in a different direction than the previous diagonal. So previous diagonal went this way. This one needs to go this way. So we can complete 4 directions of diagonal with 2 twists on either side of it and end up with a loop of 8 twists. And conveniently, when we do that, we end up with our corner touching the next twist over. So then we're going to apply the same method to get the open twist as we did off of the previous diagonal, saying, okay, my valley needs to come exactly to that point. If these points are going to touch, then my mountain is 1 space out, and just outside of that is my target triangle. So I can bring up my pleats. And get that twist in place. Then I'll use the same methods for going from this open triangle to the next closed triangle as I did in the previous one. So I go out to the next intersection that has diagonals. I make sure to run my diagonal around relative to the loop of twists that I've been working on. And then I can squash my twist. So we're working around our loop of 8, and once we do that, then we'll be able to set the spacing for our loop of 4. So next up, we've got another of these open triangles, again with the corner coming exactly to the point of the previous twist, which we can squash. And now we have 2 twists left. We're going to have a closed twist off of the open and an open twist between these 2 closed ones. So our closed twist here, we can just lay down flat while we squash the open twist, and then flip our pleat back up to set up the closed so we can squash them both. And if anyone has questions, I'm happy to answer whatever questions you have. I do have an eye on the chat. So, what do we know from here? We know that the next neighbor of this open twist needs to be closed. Therefore, it needs to be centered on an intersection with diagonals. There's not as many of those as there are intersections in general. So we have options. We can either put it here or we can put it here. And another thing that we know, we have loops of 8 and loops of 4. So the horizontal needs to connect across here. So if I were to do this densest spacing, I would end up with twists overlapping each other. And that might be something that you want. I would end up with these bits overlapping. And for today, that is not what I'm going to choose. So I'm going to choose a little bit more spacing, make it easier on us. And we've got the vertical and the horizontal, which means we need to find the diagonal that's in the middle of those two and going out, which will be aligned with the diagonal that's in the middle in between as well. And we can use that fact to make our new twist. So now we have a pleat overlap. We want to put in an open right triangle. And one of the things that we know is that we've just connected into a new loop of 8. So we can use this fact of the corners connecting to say, okay, well, my valley has to go out here, which means that the mountain is going out here. I guess that means this is my central triangle. And we can pull up all of our pleats, and indeed that is our central triangle. So from here, it might be really tempting to go ahead and complete the next loop of 8. And you would be at a natural tiling break if you did. What I would recommend if you're folding a piece that that you've intentionally centered and you're trying to fold really nicely, then maybe go around and find these 2 twists on all 4 sides of the loop of 8, and then expand a little bit more and deal with the overlaps as they come up. So one of the things that you'll start to notice when you're folding these kinds of tessellations is it's not just one loop of 8. There's actually 2 loops of 8, and they're distinct. So if we look on this example, we can see there's the loop of 8 where you can see the diagonals, and then the loop of 8 where you see the horizontals and verticals. And of course we can see a little bit of both on each of them, but this very much looks like a diagonal square, and this one looks like a horizontal and vertical square. So we've got these 2 distinct loops of 8, and then the same loop of 4 everywhere, just rotated around. So we have our two positions of fourfold rotational symmetry. So you can see this is the same in 4 rotations. And then a position of twofold rotational symmetry, the same in 2 rotations. Okay, so moving on from this one, these are general patterns that apply to all tessellations that are alternating in this tiling. I'm going to choose for today to finish out this loop of 8, work out from these diagonals, just like we did with our starting loop of 8. So off of this closed twist, we're going to need an open twist, like so. And I've been using the words closed and open a lot, but haven't shown why. It's because some of these twists come around a closed hole, and some of them come around an open hole. And you might recognize the size of this open hole. It's the same exact size as our target triangle inside of the twist. So that's the structure that we're going for when we say open versus closed. And then coming up here, I can get a partial closed twist, pivoting on this valley fold here. So I end the fold right at the edge of the paper at that grid intersection. And this is not a surprise to me because we started this twist in the exact center and I barely had enough space to finish this loop of 8. So our twofold rotationally symmetric position is up here above our center, and so I predicted in advance that we would not finish this loop of 8, which is why I was happy to do it without folding other parts first. Because as I said in the beginning, this is a very small grid relative to this pattern. So next up, here we're actually working in the opposite direction than we did the first loop of 8, and so it's actually a bit easier to find the center of our closed triangle. It's going to be one spacing out on the diagonal. We already have the diagonal, so that means the diagonal needs to split off into a horizontal and a vertical before we can squash. And then here again we have a partial twist, and this one we can't place precisely because it's going to be an open right triangle instead of closed, and so the edge goes longer before it meets the next grid intersection, longer than we have paper to put in. So I just did a squash, made it not go straight to the corner, and left it at that. So then if we look at this side of the paper, or specifically at this edge, we can see from our previous loop of 4 that we go 3 spaces between valleys. And I'm talking about these 2 valleys underneath. Well, here I've got a valley, and then 3 spaces later I hit the edge of the paper. So there's nothing more that can be done on that edge. Down below, I'm able to bring 1 grid spacing of paper in, and I can set up these partial twists by saying, okay, the closed one goes 2 spacings in before it hits a grid intersection. The open one goes 3 spaces. We can see the 3 there. Or I can say, hey, this specific point is on the opposite side of my twofold rotationally symmetric point. Therefore, it has to be that point that both corners come to. And then we can get a little bit more if we rotate our paper up here. And I'm going to start on this portion where we have the least paper, just arbitrarily. And I'm going to need to put an open right triangle in there. So if we're working with the open right triangle, we have, again, there's 3 spaces between valleys, and then the mountain one further out. The target triangle is always going to be on the far side of the mountain relative to the valley. And so it's going to be up above, and we'll get the valley of the diagonal coming in that way. And setting it up, we can go ahead and squash. Then coming over, we've got this teeny bit on the edge here that I'm going to somewhat arbitrarily squash. Needs to make a closed triangle, and yeah, it's not super important whether you do these partial twists right at the edge, but we may as well, for completeness, get more practice while we're doing our practice tessellation. And then over here, we've got that same 3 spacings between valleys. And I know that off of the open triangle, I'm going to need a closed triangle, which is going to be centered on our grid intersection with the diagonal. Our horizontal is going to go over and cause a pleat overlap, and we'll get our whole twist there. If we had more grid, we would cause another pleat overlap of the diagonals up above. But we don't have more grid, and so I'm going to resolve the one pleat overlap that does exist first with an open twist. So this pleat overlap is going to be resolved by one open and one closed twist. And I can place the closed twist most easily because it's centered one spacing out along the diagonal. And then I can use that reference to come in and find where my open triangle needs to go. And since these are far enough apart, I can go ahead and squash them both while the other is still standing. And we are going to get a partial on this open twist. Okay, so we've got just a little bit of paper left. We're going to need a closed triangle twist. Make sure that is going in and that the valley is actually on the grid line so we get the right result. And that's as much as we can fit of this tessellation on this paper. So to review, what we did is we picked 2 twists, in this case closed and open on the same side, in this general schema of right triangles. And we said, okay, how can we form a loop of 8 twists that is densest together? So we had our tips touching all the way around the ring. We can't get any denser than that. And then we said, okay, we're going to repeat this in other places. How far apart do we want these repeats to be? Do we want the paper to overlap? Do we want there to be a little bit of extra space? And so from there, we were able to set this 3 spaces. Really, we were setting 2, 4 to the center of the next closed twist. And we used the closed twist because it's easiest to locate the center, easiest to say, hey, it can go here, it can't go there. And then we use that to continue outwards, taking note of our positions of 4-fold rotational symmetry and our positions of 2-fold rotational symmetry, which are all the same, just rotated relative to each other. So then I promised one more explanation on another piece, which is this one. And so this is the exact same tiling, but it looks very different. It's very hard to tell where our loops of 8 are, for example. And in here, the loops of 8 are kind of hidden. So we've got 8 in here, and also 8 in here. So we're only seeing 4 twists on each side, but that's because the other half are on the opposite side. So it's easier to see the holes from this side than the closed holes on the other side. So we'll stay over here. And we've also got these mirror repeat structures. So what we have in this tessellation is, instead of alternating twist A and twist B, we picked 2 twists, in this case a closed and an open right triangle, put them together, connecting by their diagonal pleat, and then we drew mirror lines in a square block around that cluster. So we have 4 pleats coming out of those 2 connected pleats, and those 4 pleats are coming out in the 4 directions that form a square. So we can take this structure of 8 and 8 and 4 right triangles and morph it and make it do different things depending on what we want. And this is a topic that I went into in more depth in my Tessellations by Tiles course. One of the cool things about this tiling, the 8 and 4 right triangles, is that you can make many such blocks. So here we have mirrors around every twist. Water Strider, that I just showed you, has mirrors around a block of 2 twists without the mirror in the middle. We could also take 2 twists that form a bigger right triangle and mirror that as well. So that would be another example of mirroring groups of 2. We could make a bigger block with 4 twists, either in a square or in a right triangle shape, and mirror those as well. And so there's just so many different options for this tiling beyond alternation that I showed today. And I hope you go and experiment and explore and figure out which ones you prefer to fold. And Nancy, thank you for that comment. We have just so many options for symmetry on this. And one of the cool things is we can use some of the information that we have from before of saying, oh, these loops of 8, usually they're positions of 4-fold rotational symmetry. And you can see that really clearly when they're intersections of 4 different mirror symmetry lines. But what we have here is their intersections in the center of these loops of 8 of 2 different mirror symmetry lines. And so these positions are now twofold rotationally symmetric. And we have additional twofold rotational symmetries in each of our loops of 4, which are now distinct. So we've got a loop of 4 closed and a loop of 4 open. And so there's just all of this other ways of putting these pieces together that really helps with coming up with new designs. So happy folding, everyone. I will not be streaming next week because I'll be traveling for the Conference for Creators, and I will come back the week after to talk about odd grid divisions on squares. So see you then, and happy folding.